Hello, I'm Yasir. Today, the topic of this video is to apply the circle theorems. So there are different kind of theorems for circle, and I will bring the pictures of the theorems. So, and I will find some angle using these theorems. So one of the theorem is alternate segment theorem. Alternate segment theorem. This theorem is alternate segment theorem. What it says. So this is the theorem. This is alternate segment theorem. Alternate segment theorem says that if some tangent, so this is the tangent. Remember that what the definition of tangent to the circle? Tangent is actually a straight line that touches the circle at one point. Touches the circle at one point. It should remember that it should not cross the circle in this way. So this line would not be a tangent. So tangent is a line that just touches the circle at that particular point at which it is a tangent. So that's a definition of the tangent. So tangent is a line that touches the circle that touches the circle only on one point. And the angle here, the tangent is making the angle with the triangle. The triangle, the all the corner point of the triangle lie on the circumference of the circle. So this angle theta is the same as this angle theta. So remember this thing. It doesn't say about this angle. It doesn't say about this angle. It say only this angle theta is equal to the same angle here theta. So these two angles would be the same. It's that's alternate segment theorem says. And then this theorem is the angle at the center theorem. Angle at the center. What it says some relationship between two angles. It says some angle. Uh, Relationships some two angles. The one angle is here, this angle. So this is the angle, and suppose that this angle is 2x. When so the difference between this and this angle, so if this angle is x, so this angle would be 2x. If this is 45, if this angle 45, this that angle would be a 90. So this is the radius, CB is the radius, and CD is the radius, and AB is the chord, and AD is the another chord. Remember that not necessarily that always you will have this kind of situation. Suppose that I construct a circle in which this is a center O and this thing, and then instead of this point A, if I choose the point here, if I choose the point here, sorry, if I choose the point here, so again it will have a similar situation. It would have a similar situation that this angle and that angle would have some kind of relationship. The relationship is that if this angle is x, then the angle here at the center would be 2x. So in looking, it looks some confusing thing maybe because here the point is A is clear. Here this point is clear. When this point is suddenly come to another position, so then it looks little different than the previous one. So, but there the circle theorem which says that the angle at the center is twice the angle at the circumference. So that this angle at the circumference. So this angle, the angle at the center, this is the angle at the center, is twice, it is two times. 2 is multiplying with x. Is twice the angle at the circumference. And this is the angle of the circumference. This theorem says this kind of statement. And then now the third theorem, what the third theorem says? Third theorem says that the angle in the same segment theorem, angle in the same segment are equal. So this is the chord, this is the chord. So all these are chords, and they are not passing, and none of the chord is passing through, passing from the center of the circle. So, but here the angle in this way, this angle is congruent to this angle. If these two angles are congruent, so then these two angles would also be congruent. So these angles are congruent, so this angle would also be congruent. So that's angle in the same segment. And then the angle in a semicircle. The angle in a semicircle, so this is the another theorem that says the angle in a semicircle should be 90 degree. This, remember that here uh, the AB, the AB is the diameter. AB is the diameter. So the chord is passing from the center of the circle. So in this way, this angle would be a 90-degree angle. If the chord passes from the center of the circle, then the triangle here, this angle of the triangle would be 90 degree. So that's angle in a semicircle. Then the next is chord of the circle. So this is the chord of a circle. Which is the chord of a circle? If you have a radius, so CE is the radius. CE is the radius. If some chord is if some chord is drawn, which makes the 90-degree angle with the radius, then if if some chord intersect this radius, then these two lengths would be equal. The length here BD is equal to AD. So these two lengths would be the equal. The perpendicular from the center of a circle, it can be read as the perpendicular from the center of a circle to a chord, means that it makes a 90-degree angle. Bisects the chord. Bisect means that both lengths are equal. AD is equal to DB. Split the chord into two equal parts. And then the cyclic quadrilateral. The cyclic quadrilateral is a quadrilateral whose points lie on the circumference. So, so that's a theorem which says that this opposite angle in a cyclic quadrilateral total 180. So the sum of two opposite angle in a cyclic quadrilateral are 180. Suppose that if this angle is x, then the opposite angle would be here, which would be 180 minus x. When you add these two angles, the answer would be 180. So the opposite angle of a quadrilateral, the sum of the opposite angle in a cyclic quadrilateral is 180. So similarly, this angle, the angle here and the angle here would also be 180. Their sum would be 180. So that's about the opposite angle in a cyclic quadrilateral. And then this thing, tangent of a circle. Then it's a tangent of a circle. So here, if this is the tangent, in this picture, AB is a tangent, AB is a tangent, and AD is also a tangent. These both are tangents. So the lengths, it says that it says two things. The one is that the radius and the tangent makes 90-degree angle with each other. Radius and the tangent makes 90-degree angle with each other. That's the one thing. The another thing is that the length of this segment of line AD from A to D, AD and AB both are equal. This line means that these both are equal. So AD is equal to AB. Now we will try to bring some practice question for that. So the first question in the circle theorem would be, sometime if some student get these kind of questions, so he or she have to think, so what to do with that question. So I bring the first practice question on circle theorem. WXYZ, WXYZ, that's a cyclic quadrilateral because four corner point lie on the circumference of the circle within a circle with radius O. So yeah, that's a circle with radius O. And AB is the tangent to the circle at W. So AB is a tangent. It touches the circle at one point W. Angle AWX. Angle AWX is 53. Angle XWZ. XWZ, that angle is 85. That's already given. And angle ZXY. Angle ZXY, that's 43. So what to do with this question? The question is, prove that WX is parallel to YZ. Sometimes this kind of proof might be done using more than one way. So there can be a more than one way which can be used to prove this claim or this thing. So prove that WX is parallel to YZ. So that's a proof. So I prove this thing using a thing. Suppose if this line and this line have to prove that these two lines are parallel, so the line which connecting these two lines, if the angle here, this angle and these angles are equal, so it means that these two side of quadrilateral would be equal. So here in this case, what to do? I will extend this line. I will extend this line. I will extend it. I will extend it. When I will extend it, so I will see that how much this angle is. So this angle must be equal to this angle. If these two angles are equal in length, it means that both sides would be parallel to each other. So I will apply this kind of strategy on this particular question. So what to do now? And one more thing is that look at the cyclic quadrilateral. Cyclic quadrilateral, uh, so this one, alternate segment theorem. What the alternate segment theorem says that the angle, so according to the theorem, the alternate segment theorem, so the angle here and angle here would be the same. So how to find this angle? How to find angle this angle? So this angle can, because this is a straight line. In a straight line, the angle is 180. If it is a straight line, this whole uh, semicircle, if you have a semicircle type, not yeah, semicircle. So this angle would be a 180 degree. So half rotation. So so if you subtract 53 and 85 from 180, you will get this angle. How to get that? So it is 85 plus 53. 85 plus 53. It's 42 angle. This angle would be a 42. If this angle is 42, so this angle must also be 42 because alternate segment theorem. So this is the if this is the so what it says, look at alternate segment theorem. So this is the alternate segment theorem. If this is the tangent, if this is the tangent, so the angle, this angle and this angle would be the same. So that's what it says. The alternate segment theorem says. So according to alternate segment theorem, if this angle is 42, then this angle would also be 42. No, because XYZW is a cyclic quadrilateral, because this is a cyclic quadrilateral, so the opposite angle, the sum of the opposite angle would be a 180. So this whole angle and this whole angle would be their sum should be 180. So it's 43 plus 42. What is 43 plus 42? 43 plus 42, 85. So this angle is 85. And then the total angle is 85. No, this opposite angle would be 180 minus 85. 180 minus 85 because of cyclic quadrilateral. So it's 95. So this angle is 95. This angle is 95. If I extend this line, if I extend this line, one angle is 85, another 53. So this whole angle would be 180. So I subtract these two from 180. 85 and 53. 85 plus 53. So 180, so it's 42. So this angle is 42. Which angle? Which angle is 42? So the angle here, this angle is 42. No, this angle is 42 and this angle is 53. No. So this angle is 42. So the angle here, that angle is 42. No, this angle is 42. 42 plus 53. 42 plus 53 would be 42 plus 53 would be 95. So this angle becomes 95. Now this is 95 and this is 95. It means that both angles are the same. So this side is parallel to that. This side of the quadrilateral is parallel to that side of the quadrilateral. So that's right. So this can help me prove. Now I will move to the next practice question. So here is a circle with radius O. So no, look at that. It's a simple, I think, because the angle at the circumference and the angle here. So this angle is two times what the angle is. So if you do 108 divided by 2, you will get that angle. So according to the theorem, 108 divided by 2, so that would be a 54. So x angle is 54. It says write down the value of x, so angle x is 54. And then its next part says, so look at this again, that theorem. This theorem is this one. It says that angles in the same segment theorem. Angles in the same segment theorem. So the angle in the same segment, so the angle, this 62 would be the same as y. So y is 62. Angle in the same segment. So look at that. So again, it's because the one chord, the diameter, one chord is a diameter, and it's a right angle triangle. So the angle here would be what? The 90-degree angle. That's also says by another theorem. So because AC is a diameter, so the triangle is formed such a way that this angle would be a 90-degree. So that angle is a 90-degree. So that was just the use of the theorem. DE and F are points on the circumference of a circle with center O. Angle DOF is equal to 120. Work out the size of angle DEF. DEF. So again, that theorem. So 120 divided by 2. 120 divided by 2 would be 60. So this angle would be 60. So you can write in a reason, you can refer that particular theorem. A, B, and C are points on the circumference of a circle with center O. So center is O. AB and AD are tangents to the circle. AB, AB and AD are these both are tangents. The AB is a tangent, AD is also a tangent. So this length would be the same. And this is the radius. So this length and this is also radius. These two should also be equal. Angle BAD is equal to 70. Angle BAD, that's already mentioned. Work out the size of angle BAD. So BAD when already given, but so why to work out the size of that? I think it would be a BOD. So there will be some kind of mistake here in the question. So because BAD is already given, so I think to find BOD, not BAD. So I think to find this angle, the angle here. So if I draw the straight line, I draw a chord, I draw a chord. So because that's a isosceles triangle. In a isosceles triangle, two sides are equal. So AB and AD are equal. And so the angle here, that angle, no, one more thing is there is no need to find in this way. The another thing is that because the radius and the tangent makes 90-degree angle according to the theorem. Radius and tangent make 90-degree angle. So these two are 90-degree angle. This is 70-degree. So the fourth angle would be, because it's a quadrilateral, so its sum of interior angle would be 360. So two are 90. So 90 plus 90 would be 180. 180 plus 70, 250. So that angle would be a 110. So this angle would be a 110. So that angle. Even you can find now this angle as well. That would be half of 110. And then it's the next question. Wx Wx and y are points of the circumference of a circle with center O. ZYO is a straight line. ZYO is a straight line. ZW, Z, where is it? Oh, here. ZW, ZW is a tangent, that's a tangent. Angle WZO is 28. So what to do with this question? Work out the size of angle WOZ. Work out the angle size of angle WOZ. WOZ. So this angle. First to find this angle. How to find that angle? Look at that. So this is the radius. So this is the radius and this is the tangent. So according to the theorem, radius and tangent makes 90-degree angle. So the angle, this angle would be a 90-degree angle. Now in this triangle, one angle is 90, other is 28. So third angle would be, because the sum of the angle in a triangle are 180. So you add these two angles 90 and 28 and subtract from 180. So 90 plus 28. So that angle would be a 62. So this angle is 62. So that's done. One part is done. So this angle is 62. And now then it says that B part. Work out the size of angle WXY. WX and Y. So it's the same theorem. What was the statement of theorem? If the angle at the center of the circle is twice the angle at circumference. So this theorem will say. So this point you can consider here as this point. So angle at the circumference and angle at the center. So this angle at the center, this is the angle at the center. So 62 is the double of that. So half of the 62 would be 31. So this angle would be 31. According to that theorem. And you can write the main reason for that. What is the reason? So you can refer the theorem according to that particular theorem. In the diagram WXY are points on the circumference of a circle with center O. Angle XWZ is 70. XWZ is 70. It is not mentioned, so I mention. So this angle is 70. XOZ. XOZ. That angle is A. And XYZ, that angle is B. Work out the value of A. So what would be the value of A? So that's simple. The angle, the angle at the center is twice the angle at the circumference. So the here this angle is 70. 70 times 2 is 140. So angle A would be 140. So that angle would be a 140. And then the next question, what the next question says, work out the angle of B. Work out the value of B. So for value of B, also a cyclic quadrilateral. The one point is here, second point is here, third point is here, and the fourth point is here. The sum of opposite angle would be 180. So this is 70, and that should be a 110. So B would be a 110 because the sum of opposite angle in a cyclic quadrilateral would be 180. So this angle is 70, so that angle would be 180 minus 70, so which would be 110. In the diagram, X, Y, and Z are points on the circumference of a circle with center O. X, Y, and Z are points on the circumference. So X, Y, Z one point. So it says that ZXA is 56, ZXA, so this angle, the line AXB, the line AXB is so that angle is tangent, that is a tangent to X to the circle. ZY is equal to XY. ZY is equal to XY. So these two sides are equal. So again, angle, so that theorem, what the name of theorem is that? So it's uh, this one, alternate segment theorem. Alternate segment theorem. According to alternate segment theorem, so that's according to alternate segment theorem, the angle 56 is same as the angle 56 here. So this angle is 56. That's what the alternate segment theorem says. So also both sides are equal. So when two sides are equal, so this side is equal to this side. So this side and these sides are equal. So because these two sides are equal, so they're opposite angle. The angle to this angle, so here, this one, and angle to this. So they must be equal to each other. Suppose that this angle is theta, so this angle would also be theta. So theta plus 56 is equal to 180. So because angle in a triangle is sum of the angle in triangle is 180. So 2 theta is equal to 80 minus 50, 180 minus 56. 180 minus 56. So it's 124. So theta would be 62. So theta would be 62. So this angle is 62 because of isosceles triangle. This angle is 62, and the angle here, this angle is 62. By the way, the one more thing is that this angle because this is the tangent. This is the tangent and this is the circle. So this whole angle is 90. This whole angle is 90 and 90 minus 56, and you can find even this angle. So I'm not sure what the question says exactly. OX. Oh, it says that find the angle OXY. OXY. Find the angle OXY. So 90 minus 56. What is 90 minus 56? So it's 34. So it means that this angle, the angle here is 34. That angle is 34. What was the total angle? This total angle was 62. 62 minus 34. So it's 28. So the angle here, this angle is 28. In the diagram, X, Y, and Z, X, Y, and Z are points on the circumference of a circle with center O. So one angle is 56, which is already mentioned, and angle YXZ is 38. Find the size of angle XZW. XZW, so this angle. Again, according to the theorem that angle in the same segment are equal. So if this is 56, so this would also be 56. So this angle would be 56. If this is 38, if this is 38, this would also be 38. So here it says AB is a diameter. AB is a diameter, so it means that there is some center. So AB is the chord passing from the center of the circle, right? So that's why it is a diameter. C is the point on the circle. C is the point on the circle. D is the point inside the circle, such that DB is equal to BC. So DB is equal to BC, so both are equal. And BD is parallel to CA, and BD is parallel to CA. Calculate the size of angle BDC. BDC, this angle. Suppose that this angle is theta. If this angle is theta, so because two sides of a triangle are equal, so the angle opposite to this angle, so this angle and this angle would be the same. So the angle here should be theta as well. So this angle would be theta. No, look at this, because this is a diameter. This is a diameter. So a triangle forms a 90-degree angle here. So this angle would be a 90. The total angle is 90. If total angle is 90, and also one more thing is that if this angle is theta, if this angle is theta, because this line and this line are parallel. So if this is theta, this would also be theta. This would be theta. And because total angle is 90, total angle is 90. So the angle here, that angle would be 90 minus theta. That angle would be what? 90 minus theta. Sorry, 90 minus theta. And then because this angle is theta, so these both angle would be equal because isosceles triangle. So 90 minus theta is equal to theta. 90 minus theta is equal to theta. So from here, 90 is equal to 2 theta. So theta is equal to 45 degree. So that's done. Then the next question it says, it says VWXYZ is a cyclic quadrilateral. VZ is a tangent at A. VZ. VZ is a tangent at A. Where is A? Capital A. XYZ is a straight line. XYZ is a straight line. Angle XVY. XVY, that's 28. VWY. VWY, that's 42. So calculate the size of angle VZW. VZ, VZY. 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 Find the angle A. To find the angle A. For finding the angle A, what to do? What to do? So look at this here, alternate segment theorem. If this angle is 42, so this angle and the angle here would be equal. So this angle would also be 42. That's the one thing. No, another thing is says that if this angle is 28, so then here the angle, angle in the same angle in the same segment are equal. So this angle would also be 28. If this is 40, yeah, that angle would be a 28. Now look at that. They are the sum of 42 and 28. How much it is? 42 plus 28. It's 70. So total angle is 70. This total angle is 70. If this total angle is 70, so it means that this total angle would also be 70. So that angle, no, no, sorry, 180 minus 70, 110. So this angle, total angle would be 1 because of cyclic quadrilateral. So the sum of the opposite angle in cyclic quadrilateral is 180. So that's why this angle would be a 110. If this angle is 110, then this whole angle is 180. So 180 minus 110 would be 70. So this angle would be a 70. If this angle is 70, this angle is 42. So the A would be what? 70 plus 42. 70 plus 42 would be 112. And 180 minus 112 because in a triangle, sum of all angle is 180. So it's 68. So this angle A is 68. Then the last question. Yeah. In the diagram, A, B, C, and D are points on the circumference of a circle with center O. Angle ABCD. BCD. This angle is 128. CD is equal to BC. CD is equal to BC. So these two sides are equal. Write down the size of angle BAD. BAD. So this angle. So for doing this kind of question, so if it is 180, because the cyclic quadrilateral, if this is 180, so this that would be a 180 minus 128. 180 minus 1. So it's a 52. So that angle would be a 52. If that angle is a 52, so this angle is a twice of 52. So twice of 52 would be 104. So this angle is 104. What it says, BAD. BAD. Yeah. So BAD is 52. That's done. Oh, what the other thing is, and oh, another question is that its B part says, Write down the size of angle ODC. ODC. So to find this angle, the angle here. So for drawing that, I draw a straight line, and because this side is equal to this side, one angle is 104. So this angle, the angle here would be would be same because the triangle is isosceles triangle. So if this angle is theta, so this angle would also be theta. So 2 theta plus 104 is equal to 180. So I write 2 theta is equal to 180 minus 104. So 180 minus 104. That's 76 divided by 2, 38. So theta is equal to 38. So this angle is 38. No, about what about this angle? So this angle and this angle would be same because there are one more isosceles triangle BCD. BCD is a isosceles triangle in which the one angle is 128. So here the angle will be found as 2 theta is equal to 180 minus 128. So 180 minus 128 is 52. So that's a 52. So this angle is 2 theta. So theta is equal to 26. So here this angle would be a 26. So 26 plus 38. So this angle is 38. So that 38, and this angle is 20. So adding these two angles is 64. So the total angle would be a 64. So now I end this video. Okay, bye.